transposing a formula where one of the variables has a square or cube function in it. For example, the power formula where power is equal to voltage squared divided by resistance. If, for example, we want to rearrange this formula so that resistance is the unknown value, so we know the voltage and we know the power, what is the resistance? We can use the same methodology that we've previously learnt about transposing a formula. So what we do to one side of the equation, if we do the same thing to the other side, the equation stays balanced. And just because one side has a square function or a cube function, it doesn't make any difference. So in this case, we want to get the voltage squared away from the resistance. So we are going to divide both sides by v squared. We don't have to worry about that it's v squared, we just divide it, both sides by it. And as we've seen before, v squared over v squared would be 1, and so that would cancel each other out. And we would have power over voltage squared is equal to 1 over the resistance. Now we don't want to know what 1 over the resistance is, we want to know what the resistance is. So what we can also do is we can simply transpose or inverse both of those formulas on both sides of the equation so that v squared over p is equal to r. Now how do we do that? Well, once again, let's go back to a simple formula. If, for example, we know that 6 over 2 is equal to 12 over 4, right? Both of them are in fact equal to 3. So what would happen if we just inverted both of those? So we now get 2 over 6 is equal to 4 over 12. Do they? Yes, they do, because they both equal 1/3. So we can very simply just, if we wish to, invert both sides of an equation, and the equation stays balanced and true. And out of convention, we put the unknown on the left and the known variables on the right. Let's take another example of this formula where perhaps we want to know what v is and not v squared. How are we going to go about that? Well, we start off with our formula and we do the same thing that we've already done. We want to get the r away from the v squared. So in this case, if we multiply both sides by r, these two r's cancel out and we are left with p times r is equal to v squared. Now we don't want to know what v squared is, we want to know what v is, and so we'll put the v on the squared on the left and the pr on the right, just out of convention. And what we can simply do is we know that if we square root both sides, the square root of v squared would be equal to v, and the square root of pr is the square root of pr, as shown there. And so that is how we transpose a formula and get rid of a square or a cube function at the same time. Here's an example for you to try. If q is equal to r squared s, what is s equal to and what is r equal to? And stop the video here to work it out. The next page has the answers. Hopefully you have found that s is equal to q over r squared and r is equal to the square root of q divided by s.